Hello and welcome to this look at an applied ozone and haloalkanes exam question. This is how they would make the question A or A star challenge if they decided that that particular topic was going to be tested to that level in a paper. So let's quickly review how radicals are formed from CFCs. So if we start with this structure, chloro-trifluoromethane, what we need to do is look at the carbon-hydrogen bond enthalpies. Now these are different because of the differing sizes of the halogen atoms. As always, the larger the atom, the greater the level of shielding between the nucleus and the electrons contained within the bond between the halogen atom and the carbon. So if the halogen atom is larger, then the nuclear attraction for the bonded pair of atoms is weaker, so therefore the bond enthalpy is lower. So out of the two ones that are of interest in this particular structure, you've got the CF bond, which is 467 kilojoules per mole. That's because the fluorine atom is smaller. It's a smaller atomic radius than the chlorine atom, so it exerts stronger nuclear attraction on the bonded electrons. The chlorine atom is larger than the fluorine atom, so it exerts less nuclear attraction on the bonded electrons. So therefore the CCl bond at 346 kilojoules per mole is the weakest bond. So when it's attacked by UV light, or when UV light is shone onto that molecule, the weakest bond will break first. So that leaves behind two radicals, a CF3 radical, which is the remaining part of the molecule, and the chlorine atom that comes off with its electron, remembering it gets its electron back from the shared pair during homolytic fission. So the chlorine radical is what is actually responsible for initiating the breakdown of ozone in the upper atmosphere. So, constructing an equation to show the formation of Cl radicals from chloro-trifluoromethane is quite straightforward. We just had a quick look at it. And then it says ozone is broken down by chlorine radicals in a two-step process, and they want the equations for the two steps and the overall equation. So I'll take you through the steps and the rationale behind why they're written as they are. So the chlorine radical has to attack or react with an ozone molecule. So that leaves O2 behind, and the oxygen that was removed joins with the chlorine radical to make a ClO radical. In the second step, the ClO radical is used up. That finds a spare oxygen atom, and then it produces a chlorine radical. In other words, the chlorine is regenerated, and an oxygen molecule. So that must mean that chlorine radicals are the catalyst. So if you cancel everything out that contains chlorine, because both chlorine species appear on the left and the right hand side of the equation, that gives you O3 plus O, giving you 2O2. And you can check that against the mark scheme to see where we're at. Now the next part of the question is where it's demanding this. I referred to this question as an A-star question earlier. This is the part that challenges the most able. So taking our equation from before and concentrating first of all on the chlorine radicals. There's 1 gram of chlorine radicals, so therefore the number of moles is going to be 1 divided by 35.5, which is the relative atomic mass of chlorine. So that gives us 0.0281. I've truncated the value. And then we go to the ozone. There's 135 kilograms, but obviously we need to use that in grams when we're doing mole calculations. The molar mass of ozone is 48 grams per mole, so that gives us 2,812.5 moles. So there's a ratio between those two numbers. Now, as always, you can turn a ratio that's not in whole numbers into a whole number ratio by dividing through by the smallest. And that gives us 99,844 to 1. So in other words, that means there's 99,844 ozone molecules that are removed by 1 chlorine radical, because obviously it can go back and do the same process a number of times because it's catalyzed. It's a catalyst, so it's regenerated at the end. But they want it in standard form and 3 sig figs. So therefore that means it's 9.98 times 10 to the power of 4. So checking the mark scheme, you can see where the marks would have been awarded. Okay, thanks for listening. Until next time, see you soon.